Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine if two functions are inverses of each other's formally. And basically what we're going to do is we're going to compose both of our functions. We're going to do fg of x and g of f, or g of f of x. And when we compose one function, if they both give us our identity function, which is just x, then we have inverses. If we do not, then they are not inverses. So again, basically to be able to prove that two functions are inverses, we talked about how to find the inverse of a function, but to prove that they are absolutely inverses of one another, then we have to be able to show that fg of x is equal to x and g of f of x is equal to x. So they both have to be true for us to be able to show that they are inverses. So basically all we're going to go through on this is basically all we're simply going to do is just going to compose each one of these functions. Now I think I got enough room, I do. All right, so the first thing we're going to do is do fg of x. Then we're going to do g of f of x. OK, so let's go ahead and do fg of x in this function. Now, if you remember, when we're doing f of g of x, or fog, basically what we're doing is we're plugging the g of x function into the f of x function for the input value x. So that's going to look something like this. So we can say, why don't I just write that above there? That makes no sense. Let's do f of g of x is going to be 2 times x over 2, right? So basically what we're doing is instead of x, we're plugging in the g of x function, which is x over 2. Now remember, when you're multiplying a number times a fraction, you can rewrite your whole number as a fraction. Therefore, we have numerator times numerator, denominator times denominator. The 2's will divide out, and we're just left with x, which is our identity function. So it works that way, but we also got to confirm that g of f of x works as well. So I'll just do that right below. I'm not going to. So now what we're going to do is plug the f of x function in for the g of x function, again using these parentheses. So therefore, I have 2x divided by 2. Right? You can see now I took my f of x function, plugged it into my g of x. Well, again, here, the 2's divide out, and we're just equal to 1. So guess what? F of x and g of x, in this case, those are inverses of one another. Now let's go ahead and move over to our next example. So again, we're going to do the f of g of x first. You don't have to do this one first. You could do g of f of x. But I'm going to plug my g of x function in for f of x. So it's going to look something like this. 3 times x minus 8 divided by 3 plus 8. OK? Now, just like we had over here, the 3, that's really in the numerator. And that's in the denominator. And it's a cross multiplication, so those can divide out. Then we're left with x minus 8 plus 8. So I have x minus 8 plus 8. Well, we know those are going to just add to 0. So I'm just left with x. OK? So it's looking good, but we got to be able to show that it works for g of f of x as well. So I do g of f of x. OK, we're doing g of f of x. Now I'm simply going to plug in my f of x function in for g of x. So I have 3x plus 8, which is my f of x. And I'm going to plug that in for x in my g of x, which would be minus 8 divided by 3. Well, the first thing you notice is we really don't need the parentheses. First thing we notice is the 8 minus 8. That's going to go to 0. So therefore, I'm left with 3x over 3. We know the 3's divide to 1, just leaving us with x. All right, so we're 2 for 2, right? We got 2 inverses. So maybe that tells us that the next one is not going to. I don't know, but maybe. So let's just go and look at it. Again, I'll start with f of g of x. So I'm going to plug my g of x function in for my f of x function. So in this case, I have 2 times x plus 2 divided by 7 minus 7. No, divided by 7. Oh, that's minus 7. And that's divided by 7. OK, so main important thing here is you notice that this divided by 7, I can't divide these two out because that's separated by subtraction. So you can't divide across addition or subtraction. So I can't really do anything with 7. The 7 doesn't divide into the 2, nor does it divide into the 7. So really, I can't do anything with this. I can apply distributive property here. 2x plus 4 minus 7 divided by 7. That becomes 2x minus 3 divided by 7. But what you see here is then we come to another stalemate. I can't simplify this just to get x. So therefore, this is an example of two functions that are not inverses. Okay, so the only way we can prove formally that they're inverses is by taking the composition of f of g of x and g of f of x, and when we get the identity function x, then we can show that they are inverses. Thanks.